So today we are discussing about the chapter that is the third chapter in chemistry, chemical kinetics. So first we will discuss some important points regarding this chapter and later we will move to the past paper questions. Okay? So in between, if you are having any doubts or anything, you can ask me. So let's start from the important equations, important points that we have to remember. Okay. So let's start now. So the chapter is chemical kinetics. First of all, the chapter chemical kinetics actually dealing about the rate of the reactions and how the rate of the reaction is depending on several factors and what are the factors affecting the rate of the reactions and how they are affecting. Okay, then what are different, what is order, what is molecularity, and how these order and molecularity are different. So we have to discuss too many things and we can expect the questions from these topics as well. Means in every, so like order, molecularity, all the topics are important, so you can expect questions from any. So we have to go through the important points, important equations first. Okay, so first let me introduce what is a rate of reaction. So rate means how fast the reaction is or how fast the reaction is going on. So in every reactions we know the reactants will be converted into the products, right? So how fast the reactants are converting into the products or how fast the products are producing, how fast the reactants are consuming. That is simply called the rate of the reaction. So we can explain or we can define the rate of the reaction in terms of both the concentration of reactants as well as the products. Because as time is increasing, as the reaction is going on, the concentration of the reactant will decreases because they will be converting into the products, right? And when time is going on, the concentration of the products will increases. So that is the rate of the reaction. So it is the change in concentration of the reactants or the products with respect to time. Okay, now we have two different types of rate. Like rate is always same, but we can define the rate in two ways. The first one will be the average rate of reaction, and the second one will be the instantaneous rate of reaction. Okay, so average rate means here we have to know the equations. That is the thing. So here we have the hypothetical reaction, that is A is converting into B, and we are representing the average rate first. So average rate means here A is the reactant, B is the product, right? So as time is going on, the A concentration of A will decreases. So we have to define with a negative sign. What is this negative sign denotes? Negative sign means the concentration of the reactant is decreasing. So this decrease in the concentration is actually denoted by the negative sign. While going to the products, we know the product concentration will increases, right? So in case of the product, we have to write positive sign. So this is the average rate, that is change in concentration of A divided by change in time. So this sign delta denotes the difference between the concentrations of the reactants at a particular time interval. That is, suppose if I am measuring that reaction between time t1 and t2. Okay, so when time is increasing from T1 to T2, there will be a change in concentration. Suppose at T1 the concentration was A1, at T2 the concentration was A2. So the change in concentration will be delta A and the change in time will be delta T. So this is the average, means we are taking a particular time interval in case of the reactant, or it is product also same. At T1 it may be B1, at T2 it may be B2. So change in concentration with respect to the change in time. Okay, and the unit of the rate should we have to know, because we know rate is the change in concentration divided by time, right? That is, we can simply we can write change in concentration by time. So what is the unit of concentration? Concentration is equal to n by v, that is the number of particles per volume. So number of moles or number of particles means we have the unit, that is mole only. And coming to the volume, volume means we can usually we are expressing in liter or decimeter. Okay, so if it is in liter, we can write mole divided by liter. The unit will be mole divided by liter. Okay, So concentration divided by volume, that is mole divided by liter. So we can write it as mole liter raised to minus 1. So mole liter raised to minus 1 is the unit of rate. Okay, so coming to the sorry, the mole liter raised to minus 1 is the unit of concentration. Concentration is equal to n by v. So now I am moving to the rate. Rate means concentration divided by time, right? So concentration is mole liter raised to minus 1, and time. Time means usually we are expressing in seconds. So what will be the unit of this rate? Rate is equal to concentration by time. The unit of concentration is moles per liter, and unit of time is second. So the total rate means unit of the rate we can write mole liter raised to minus 1 second raised to minus 1. So that is the unit. Okay, so using this way we can find out the rate of the reaction. Now we are coming to the instantaneous rate. So what do you mean by instantaneous, right? So average rate means it was the rate of the reaction within a particular time interval, right? So if you're coming to the instantaneous rate, it means it's the rate of the reaction at a particular time only, that is at an instant. At a particular time, what is the rate of the reaction? So here we have taken delta. Delta means it is the change between a particular time interval, but instantaneous rate means at a particular instant. So it is usually denoted by d by dt. Here it was delta by delta t. D by dt means it denotes the particular time interval only. So the same here, in case of the reactant we have to use the negative sign. In case of the products there is no any negative sign, because the when the time is increasing, concentration of the product is increasing. When time is increasing, concentration of the reactant is decreasing. So negative sign for the reactant and positive sign for the products. Okay, that's it. Now we have to write the rate equation. So we have a general reaction, that is AA plus BB is producing CC plus DD. So what is the rate equation for the given reaction? So in order to represent the rate of a reaction, we have to use this expression. That is, here two reactants we have, they are A and B. The products are C and D, right? Then we have the coefficient of A, that is small letter A, coefficient of B, small letter B, C is C, D is D. So while if you are writing the rate equation, we have to consider the coefficient as well. So what are the reactants here? Reactants are A and B, right? So both concentration of both A and B will decreases with respect to time, right? So in both those cases, we have to use the negative sign that is given here. Now, coming to the coefficient. The coefficient of the reactant term should be written as 1 by A. But here, because the coefficient of A is small letter a, right? So if you are writing the rate of the reaction in terms of A, that will be minus 1 by A dA divided by dt. This is the instantaneous rate. Okay, we are not writing delta, we are writing D. That is the instantaneous rate of the reaction with respect to the concentration of the reactant A. Okay, now we can write the rate of the reaction in terms of B as well. So if I am writing in terms of B, it will be negative 1 by B. This 1 by B means coefficient of B is small letter b here. So minus 1 by B d by dt of concentration of B. Now coming to the product C and D. C and D means they are products. So the concentration of C and D are increasing with respect to time, right? So we have to use the positive sign in both cases. And same as before, we have to use the coefficient as 1 by D and 1 by C. So 1 by C d by dt of concentration of C, 1 by D by dt of concentration of D. This is how we are expressing the instantaneous rate of a reaction in terms of all the reactants and the products. Okay. Now, what are the different factors affecting rate of the reactions? So we have several factors which can affect. So the important factors are, first one, the concentration of the reactants, the nature of the reactant, temperature, pressure, surface area, and presence of light. So among these six, fives are important. The presence of light is not that much affecting, but the remaining five factors are very important. First one, concentration of the reactant. So we know that every chemical reaction takes place by the collision between the reactant molecules, right? That is collision theory. But all the collisions, collision means the particles should hit each other, right? But all the collisions will not lead to the reaction. There should be some successive collisions. So what do you mean by the successive collisions? As we all know, successive collision means the colliding particles should have a minimum amount of energy. That minimum amount of energy is called the activation energy of the reaction. So in order to take place a chemical reaction, the colliding particles should have a minimum energy for their collision. So if the colliding particles are colliding with less amount of energy, it will not lead to the chemical reaction. Okay, so they should have a minimum amount of energy. That energy is called activation energy of the reaction. Okay, so this is the collision theory. So in terms of the collision theory only, we can explain these factors, how they are affecting the rate. First one is the concentration of the reactants, right? So when the concentration of the, what is concentration? It is number of particle per volume. Okay. So when the concentration of the reactant is increasing, more particles will be available. That is the number of particles per volume means concentration increasing means more particles will be present in a particular volume. Okay. So when these number of particles increases, what will happen? More particles means the collision chances are also increasing, right? Because the particles will be close together, so they will collide faster. As a result, the rate of the reaction will increases. Now coming to the nature of the reactants. The nature of the bonds means in order to take place the chemical reaction, they should collide. In order to collide, the atoms will be free. If it is a molecule, before the collision, the molecules will convert into the atoms, and these atoms are actually combining together. These atoms are actually colliding together. Okay, so the nature of the reactants means if the bonds between the atoms in the reactant should be, means it should be weak. Weak means it should be easily breakable. They should collide easily. Then only the rate of the reaction is increasing. So nature of reactants is also important. Now next one is another important factor, that is temperature. So temperature means we have to provide the heat energy. In order to increase the temperature, we have to provide the heat energy. So when temperature is increasing, what will happen? The energy of the particles, that colliding particle is increasing, so the number of collisions or frequency, number of collisions per unit time is increasing, rate of the reaction is increasing. Now, catalyst. Catalyst means it is an external substance that can increase the rate of the reaction without participating in the reaction. That is a catalyst, right? So catalyst is not participating in the reaction, but they can decrease the activation energy and they can increase the rate, because activation energy is always acting as an energy barrier. So the reactant molecules should pass or should cross the energy barrier, then only they can lead to the formation of the product. So what the catalyst is doing, they are decreasing the activation energy, they are decreasing the energy barrier, and they are increasing the collision chances and increasing the rate of the reaction. Now coming to the surface area. The surface area of the reactants is only for the solid reactants. Okay, so in case of the solid reactants, when we break down the solid reactants into smaller particles, the area of the particle will be increasing, right? When you break down into smaller granules, the area, surface area is increasing actually. So when the surface area is increasing, the collision chances will increases, collision will increases, and rate of the reaction will increases. That's it. Okay, and next one is the presence of light, means the reaction rate normally becomes faster in presence of light, but this is not for all the reactions. This is for some specific or rare reactions only. So the first five factors are very important. Okay, now we have rate law and specific rate constant. So we discussed about the equation, how to express the rate of the reaction in the previous, right? So instantaneous rate we already expressed. Now we have to know the rate law and specific rate constants. So according to rate law, the rate of the reaction will be always proportional to the reactants, concentration of the reactants. So here we have a reaction that is AA plus BB is giving some products. So the rate of the reaction is directly proportional to the concentration of the reactants. And in here we have to see that the coefficient of the reactants are raised as the power of the concentration term. Okay, so it will be A raised to A times B raised to B. And in order to change the proportionality constant, we have to put the constant that is called rate constant. Okay, so rate is equal to rate constant K times concentration of the, means the product of concentration of the reactants, and the coefficient of the reactants should be raised as the power of the concentration terms. That's it. So this is called rate law, and K is called rate constant of the reaction. Okay, K is rate constant. Okay, so this expression is usually called rate law expression. So we are expressing the rate of the reaction in terms of the reactant concentration, that is called rate law expression. Okay, now what is the unit of K? Rate constant in terms of the concentration. So if you are considering the rate equation like this, that is K times A raised to X. X is the coefficient of A. Suppose in some other hypothetical reaction. Okay. So the unit of concentration, we know that will be moles per liters, right? Because concentration C is equal to N by V. N is mole and V is volume, that is in liters. So it will be mole liter raised to minus 1. So if you write the constant unit of K, it will be, suppose it is mole by ls right to x. X means whatever. Suppose here if it is 1, it will change. If it is 2, the x value is 2, this value will change. So we can take it as a common value x. X may be equal to 0, x may be equal to 1, 2, 3, whatever. Okay, then unit of K will be like this. So this equation we have to remember, because you know the order of the reaction, right? So for different orders, we have different units. So this equation we have to memorize, then only we can change this expression for different order of the reaction. So X we can consider as the order. Okay, suppose you are taking X as 1, what will be the unit of K? Then it become mole raised to 1 minus 1, because I'm taking X is equal to 1. So it will be mole raised to 1 minus 1, then liter raised to 1 minus 1, second raised to minus 1. So you by combining this, mole raised to 1 minus 1 become mole raised to 0. Mole raised to 0 is 1, because x raised to 0 will be 1. So mole raised to 0 is 1, liter raised to 0 is 1. So the remaining will be second inverse. So for if x is equal to 1, that is a first order reaction, the unit of K will be second inverse. So based on the rate order of the reaction, we can find out the value of unit of rate constant. Okay, so this equation is important. Now molecularity and order. So this molecularity and order, both of them are actually different terms. Usually the students, they might think about this order and molecularity, they will be same, but it is not same, it is different. Okay, so molecularity means it is actually how many number of particles are taking place in the reaction. So from the equation, we can say how many particles are there. Suppose, for example, I will tell you A plus B plus 2C is producing some products. So here molecularity will be what is the total number of particles. Here we have 1A, 1B and 2C. So the total number of particle will be 1 plus 1 plus 2, that is 4. So 4 particles are there, means the molecularity will be 4 here. Okay, so that is the molecularity of the reaction, whatever the number of particles are reacting, and how that is called molecularity, and it should be always a whole number as well. Never be zero, negative or fractional. Why? Because zero number of particles are reactant particles means there is no reaction, right? So the molecularity never be zero, and it is never be negative, because minus one number of particles are reacting. We can't say that, right? So it should be always a whole number and not fractional as well. Okay. Now, order of the reaction. This is different from the molecularity. Order means it is, molecularity means from the equation we can find the molecularity of a reaction. But order means we cannot find it from the reaction. Okay, we have to find the order by experiments. So it is an experimental quantity. Order is an experimental quantity. Okay. So usually if suppose we have a rate expression, here overall order of the reaction means it will be the power, sum of the powers of the concentration terms. So it is alpha plus beta. That is the order of the reaction. Okay, and it is an experimental quantity. If you compare the molecularity and order, molecularity was a fraction. It is not a fractional, negative or zero. It is a whole number always. But order may be zero, negative or fractional or whole number. Okay, that is the difference between molecularity and order. Okay, now integrated rate equations and half-life. We know what is half-life. That is the time required for the reaction to complete half. Means the time required to complete the half of the reaction is called half-life time. Okay, and the integrated rate equation half-life periods are different for the reactions of different order. So we have different, or now we know what is the order. Okay, so zero order, first order, second order, different. So the half-life and the integrated rate equations will be different for different order of the reactions. Okay, that one. Now coming to zero order reaction. Zero order reaction means we know the rate expression. Rate is equal to rate constant a raised to 0. So this is a rate expression for a zero order reaction. So we can write it as rate is equal to a raised to 0 will be 1. So rate is equal to k itself. That is a zero order reaction. Means in case of a zero order reaction, the rate is independent of the concentration. Right. The rate is equal to rate constant only. But if it is a first order reaction, it will be rate is equal to rate constant into concentration of A raised to 1. It means rate is proportional to the concentration of A. But here rate is independent of the concentration. It is depending only the rate constant. Okay. And this equation to find out the rate constant for a zero order reaction is also important. That is the concentration at a time t minus initial concentration divided by time. Okay. Now we have to, this is a table to represent the rate law equation, the rate constant, half-life period of the different order of reactions. So usually the important type of reactions are zero order, first order, second order. So we have to know the rate law equations, expression for rate constant, half-life period of these three types: zero order, first order, second order. So this table give you a simple idea regarding this. So this is very important. Okay. So for a zero order reaction, order will be 0 and rate will be k, and the rate constant expression also we have to know, and t half. Okay. So for first order, it will be k into concentration of the reactant, and rate constant is having another equation, that is 2.303 by t logarithm of initial concentration by final concentration, and t half is equal to 0.693 by k. And for second order reaction also it is different. So these equations for the calculation of half-life and the calculation of rate constant, these equations are very important. We have to know this, because in NEET questions they will ask for the rate constant, they will ask for the half-life. So that time we don't have time to derive the equations, right? So we are not wasting the time to derive the equations. If you know these equations, you can just substitute the values and we can find the answer. So please memorize these equations for the calculation. Okay. Now, so next one is the effect of temperature. So before we already discussed that the temperature is actually affecting the rate of the reaction. When temperature is increasing, the rate of the reaction will be increasing. How? Because the number of collisions increases, so the rate of the reaction will increases. So the effect of temperature on rate of the reaction can be explained by the Arrhenius equation. This is also important. Okay. So what I mean by Arrhenius equation. Arrhenius equation usually explains how the temperature is affecting the rate of the reaction. So here we can see the chemical reaction with a rise in temperature by 10 degree, the rate constant is nearly gets doubled. What it mean? The temperature is having that much effect on the rate of the reaction. That's why even a 10-degree increase in temperature can cause an increase in the rate of the reaction twice. Okay, so the effect of temperature on the rate of the reaction is very, very important. So the value of the temperature, so there is a, this is usually expressed in terms of temperature coefficient. So what is the temperature coefficient? So this is the ratio of the rate constants differing by the temperature of 10 Kelvin. So this is what I said before. Even a 10-degree increase in temperature can increase the rate of the reaction twice. So that ratio is called temperature coefficient. That is the rate of the reaction at Kt plus 10 and Kt. That will be always, that's what is, they will be doubled, right? So that is equal to 2. So this effect is usually explaining by using the Arrhenius equation. So Arrhenius equation is important. K is equal to A e raised to minus Ea by RT. So K is the rate constant. A is the Arrhenius parameter. That is a constant only. Arrhenius constant. Okay. Then Ea is the activation energy of the reaction. R is the gas constant. T is the temperature. Now we can rearrange this equation by taking logarithm on both sides. So it will be ln k is equal to ln a minus Ea by RT. And if you are converting this ln into natural logarithm by multiplying with 2.303, it becomes log k. Okay, then 2.303 will come here. So log a will be a constant, E0 by. So this equation is also important. Now, what is the use of this equation? This is helping to explain the effect of temperature on the rate constant or rate of the reaction. So if you draw the graph between 1 by t and log k and 1 by t, from this we will get a straight line with a negative slope, because we know the equation of straight line is y is equal to mx plus c. Right. So m is the slope of the reaction. X is the terms that we are taking in the whatever in the x-axis value. Y means the y-axis value. Here C denotes the y-intercept. So this is the equation of a straight line. If you are drawing a straight line using this equation, it will be like this. Means this is y, this is x. So the slope of this line will be m. Yeah, okay. And this is called y-intercept, that is denoted as C here. So this is a straight line. This is a graphical representation for a curve with an equation y equal to mx plus c, equation of a straight line. So this y equal to mx plus c we can compare with the given equation. So what will be that? See, here we can write, I will compare this straight line with this given equation. That is log k will be y, this is c, and here Ea by 2.303 r. Okay, this quantity I am taking as m. Okay, then the remaining will be 1 by t. So here x is 1 by t, y is log k. So 1 by t is x. Okay, so now you can compare, that is y equal to mx plus c. So y equal to minus mx plus c. What is the difference between these two? Here m is having a positive sign, here m is negative. So if m is positive, this is a straight line with a positive slope. So if you are drawing for y is equal to minus mx plus c, the graph will be like this. The straight line will be there, but it will be a negative slope. Okay, so if you compare this equation with this one, and you can write the Arrhenius graph, or you can draw the graph for Arrhenius equation by this, the 1 by t, that is the x value here, log k value is here. Now this is the y-intercept c, but wherever it is meeting up, that is the y-intercept, and this is having a negative slope. Okay, this is the graphical representation for Arrhenius equation. Okay, now activation energy. So as we discussed before, every chemical reactions happens when the reactant molecules are crossing the activation energy barrier, right? So if the activation energy of the reaction is very high, the rate of the reaction will be like, it will take more, the reactant needs more energy to overcome, right? So activation energy of the reaction should be less than only a sufficient amount of reactions, sufficient amount of collision will takes place. So here we know the catalyst, right? So catalyst can increase the rate of the reaction. So during explaining the factors affecting rate of the reaction, we explained that the catalysts are increasing the rate of the reaction without participating in the reaction. Okay, so here you what is the catalyst they doing actually? They are providing some other pathway with less activation energy. So if the activation energy is less, the reaction become easier, right? So the catalyst is usually providing an alternate pathway with less activation energy. So here we can see two graphs. The first one is the absence of the catalyst. The second one, this dashed line, is the reaction with the catalyst. So what is the activation energy? Activation energy is the difference between the energy of the reactant and the peak of the curve. So the activation energy is less for the dashed line, right? It means in presence of the catalyst, the activation energy is decreasing. So more reaction will take place. That's it. Okay, so that is the role of catalyst in activation energy. Now we already discussed about collision theory. That is, according to collision theory, in order to take place the reaction, the reactant molecules should collide with each other, and the collision should be successive collisions as well. Okay, so here we can see some equations. That is, the threshold energy is equal to activation energy plus average energy of the molecule. So these equations are also important. And here we have another equation for the value of rate constant K and rate. So these equations are important for our calculations. Okay. So this is all about the topics that we have to prepare for our NEET exam. Okay, these are the important topics from the chapter. Fine. Now we have to explain, we have to go through some past paper questions. Okay. So here we have a data regarding the reaction between the reactants A and B. Okay. So we have to predict the order of the reaction with respect to the reactant A and reactant B. So here the rates are given and the concentrations of A and B are also given. Okay, so we have to predict the order of the reaction with respect to each of the reactants. Okay, so first let us take the rate of the reaction is equal to rate constant times the concentration of A raised to X, concentration of B raised to Y. So here I have to find out the value of X and Y. X is the order of the reaction with respect to A and Y is the order of the reaction with respect to B. Okay. So here we have the rates, that is 2 times 10 to the power minus 3, 4 times 10 to the power minus 3 and 1.6 times 10 to the power minus 3. So first I am taking the first rate, that is 2 times 10 to the power minus 3, that is equal to, I don't know what is the value of X and Y, but here the concentrations are given. Okay, that is 0.1, 0.1 molar A and 0.1 molar B. So the rate constant is also not given. I'm keeping it as K only. 0.1 raised to X, 0.1 raised to Y. So similarly for the second equation also I can write second rate is 4 times 10 to the power negative 3. Rate constant I am not changing because rate constant is a constant for every reaction. Means for each of the reaction there is a value of rate constant. For the given reaction between A and B, the rate constant is a constant. If you are changing the concentration of the reactant also, the rate constant will not change. Okay, it is depending on the temperature. So here I am writing 0.2 raised to X, 0.1 raised to Y. Now for the third one also I can write 1.6 times 10 to the power negative 2, 0.2 raised to X, 0.2 raised to Y. Okay, now what I am doing here is, and here this is the first equation, second equation, third equation. I am taking 2 by 1. Okay, so I can write 4 times 10 to the power negative 3 divided by 2 times 10 to the power negative 3, that is equal to x 0.1 raised to y divided by k 0.1 raised to x 0.1 raised to y. Hmm. So I can write it will be 4 by 2. So 10 to the power minus 3 will be cancelled. 4 by 2 means it is 2 only. So I can write 2 by 1, that is equal to k 0. So k will be cancelled, right? Both are same. 0.2 raised to x, 0.1 raised to y. The 0.1 raised to y will be also cancelled. So 0.2 raised to x divided by 0.1 raised to x is remaining. 0.2 raised to x divided by 0.1 raised to x. This is equal to 2 by 1 raised to x. So 2 by 1 is equal to 2 by 1 raised to x means here we can conclude x value will be 1 and here the y terms are cancelling. It means y value will be 0. Okay, so here the value of x is 1. Now we have to find out the value of y. So we can substitute any of the value of x in any of the equation. Then we can calculate the value of y. So if you do that, you will get the value of y that is equal to 2. So the correct answer will be option C. Here we have four different graphs. We have to find out the one which represents the variation of ln k versus 1 by t in accordance with Arrhenius equation. So this is what we explained before, because here we have the graph between ln k and 1 by t, and I told you this is a straight line with a negative slope, right? So using the same, we can find out the correct answer will be C. That is, this is equal to y is equal to minus x plus c. Similarly, we have the equation log k is equal to log a minus a by rt. Okay, and here we have a constant 2.303. Okay, so this will be y, this will be c, and this is like minus x. So x is 1 by t and the slope will be minus ea by r. Okay, so this is the equation. So the correct answer is C. Here the question is, the rate of a specific means a certain reaction is given, and it is given that the initial concentration of A is tripled and the concentration of B is keeping as a constant. So what will be the initial rate? What will be the change in the initial rate? So here the rate of the reaction is given, rate expression is given. That is, first we can write the rate expression. Rate is equal to K times concentration of A the square times concentration of B. Now it is given that the initial concentration of A is tripled. So A become 3A, right? Tripled means it become 3A. And B is keeping as a constant, so B is equal to B itself. Now we have to rewrite the rate equations with the new concentrations. So we can write rate is equal to rate constant K, A become 3A, right? So it become 3A square and B is B itself. So again we can write K is equal to 9A square B. So here this A square B is the initial rate, that is K into A square B is the former rate only. So I am writing the former rate. Okay, so here K into S, so I can write it as 9 into K concentration of A square concentration of B. So we can write the new rate, right? New rate will be equal to 9 times the former rate. Because K times A square into B will be the former rate of the reaction. So we can say that when we increase the concentration of A 3 times, the rate of the reaction is increasing by 9 times. So here first factor is increases by 3 is wrong. Second one is also wrong because it says that decrease by 9 factor. It is wrong. Increase by 6 factor is wrong. The correct answer is D. That is increase by a factor of 9. Next question. It is given that for a first order reaction, the reactant A is converting into the products. The initial concentration of A is given as 0.1 molar and it becomes 0.001 molar after 5 minutes. So what will be the rate constant of the reaction in minute inverse? Okay, so first let us see what is the order. The order of the reaction is first order, right? So the initial concentration of A is zero point 0.1. Here we have only one reactant, that is A only. Okay. So initial concentration is zero point 0.1 and after 5 minutes the initial concentration is reducing to 0.001. So what is the rate constant? So first of all we have to write the expression for rate constant of a first order reaction. So for a first order reaction, we can write the expression that is K is equal to 2.303 by T logarithm of initial concentration divided by final concentration. Now we can substitute the value. Here A0 denotes the initial concentration of A and A is the final concentration of A. Okay. Now we have to find out the rate constant. K we have to calculate. So the time for the conversion means zero point 0.1 molar is reducing into 0.001. So the time required for this reduction is 5 minutes. Okay. So we can write the A0 is given as 0.1 and after 5 minutes it will be 0.001. Now we can write the expression for K, that is 2.303 by T. I'm not converting it into any minutes or anything because our rate constant we need in minute inverse only. Okay, so we can keep the time as minute only. If the rate constant, if they are asking for second inverse, the time is given in 5 here, we have to convert it into seconds. But here the rate constant for the reaction in minute inverse we have to calculate. So no need to convert here. So we can take it as 5 only. No need to convert into seconds. So logarithm of 0.1 divided by 0.001. Okay. Now if you calculate this one, you will get 2.303 by 5 logarithm of 10 square, that is equal to 2.303 by 5 log 10 to the power 2 means it will be 2 only. Okay, so if you calculate this one you will get 0.9212 minute inverse. So the calculation we have to do, then you will get this final answer 9212. So option A is the correct one. The next question, the slope of the Arrhenius plot in ln K versus 1 by T of a first order reaction is given. That is 5 times 10 to the power 3 K. And we have to find out the activation energy of the reaction. Okay, so first of all we have to write the Arrhenius equation because the Arrhenius plot is mentioned here. So we have to write the Arrhenius equation. So K is equal to A e raised to minus EA divided by RT. Okay, now we know how to find out the values. We know we have to take the logarithms. So log K will be equal to logarithm of A plus logarithm of E raised. We can take the natural logarithm first. Okay. Before that we have to take the ln. Okay. Ln K is equal to ln A plus ln e raised to minus ea divided by RT. Okay, now we can write this equation. We know that for the plot between, okay, before that we can rearrange this again. Ln k is equal to ln a minus ea by RT. Okay, so here they are asking the slope of the plot between ln k versus 1 by t. So here we are considering 1 by t in the y-axis. Okay, so we can write it split like ln k is equal to ln a minus ea by r into 1 by t. Okay, so from this equation we can write, we know the equation for straight line y equal to mx plus c. Okay, so if you compare this equation with the obtained equation, here y will be equal to ln k, ln a is the c, minus a by rt is mx. Here x is 1 by t, m is minus Ca by r. So y is equal to c minus mx. Here it is positive slope, here it is negative slope. That is the difference. So the slope is minus Ea by r, right? So we can write slope is equal to minus Ea divided by r. Okay, so we have to find out the slope and we have to find out the activation energy. The slope is given as 5 times 10 to the power 3. So we can rearrange this equation for the value of EA, that is minus slope times R. So here we can write 5 times 10 to the power 3 times R value is 8.314. So if you multiply these values, you will get 41.5 10 to the power 3 joule per moles. So here we need it in kilojoules. All the answers are in kilojoules. So we can convert this value into kilojoule. Then it become, you have to divide with 1000. So it become 41.5 kilojoules. So B is the correct answer. So next question. Here the rate constant for a first order reaction is given 4.66606 times 10 to the power negative 3 second inverse. We have to calculate the time required to reduce 2 grams of the reactant to zero point 0.2 grams. Okay, so this is a first order reaction, right? So for a first order reaction, we have the equation to calculate the rate constant. K is equal to 2.303 by T logarithm of initial concentration divided by the final concentration. This is the equation for a first order reaction because it is given that the reaction given is a first order reaction. So no need to confused. So here we can find out the value by substituting the equation because we have to find out the time required for the conversion. So we have to find out the value of T. The values are given. K is given. The initial concentration is given, that is 2 gram. Final concentration is given, that is zero point 0.2 grams. And K value is also given 4.606 times 10 to the power negative 3. So we can rearrange this equation for T, that is 2.303 by K logarithm of initial concentration divided by final concentration. Now we can substitute, right? 2.303 by T. What is sorry, 2.303 by K? K is 4.606 times 10 to the power negative 3. Okay, sorry, we can write it as 10 cube divided by 10 divided by 2. Okay, so here if you calculate this one, you will get the final answer, that is 500 seconds. So option A is the correct one. The next question. The rate constant for a first order reaction is K and the time required for the completion of 99% of the reaction we have to calculate. Okay, so first it is So first it is given that the reaction is a first order reaction. So for a first order reaction, we know the equation for the rate constant K, that is equal to 2.303 by T logarithm of initial concentration divided by the final concentration, right? So it is given that the reaction is finishing 99 percentage. So we can take the initial concentration as 100, and after completing the 99 percentage, the remaining percentage will be 1. Okay, so we can find out the value of t here, and no other values are given because of all the options we can see it is in terms of k only. So no need to substitute the value, no need to find out the value of k. Directly we can write. So we are rearranging this equation for t, that is 2.303 divided by k logarithm of initial concentration is 100, final concentration is 1. So it will be 2.303 by k logarithm of 100 by 100 means 100 only. So we can write it as 10 to the power 2. So it will be 2.303 by k. Logarithm of 10 to the power 2 means it is logarithm of 10 to the power 2. So it will be 2 only. So we can write 4.303 times 2 means it will be 4.606 divided by k. So the correct answer is C. Next question. The mechanism of a hypothetical reaction is given here. We have to find out the overall order of the reaction. So for a multi-step process, the overall order will be depending on the slowest step. Okay. For a single step process, it is not an issue because for a single step, the rate will be depending on the same. But for a multi-step process, it will be depending on the slowest step. Okay, so here we have three different steps. First one is X2 is converting into two X atoms. In the second one, X is combining with Y2 and producing XY plus Y. The third step, X and Y combining together to produce XY. So what is the order? So here we can see the second step is given as the slowest step. So the order rate of the reaction will be depending on the slowest reaction only, right? So how to find out the overall order? So in order to find out the overall order, we have to assume that the first one is reversible. So we can write the equilibrium constant for the first step, that is K equilibrium is equal to the product concentration, that is two products we have X and X, divided by the concentration of the reactant. So it become okay. Now so the question is, a first order reaction has a specific reaction rate of 10 to the power negative 2 second inverse. So we have to find out the time that it take for 20 grams of the reactant to reduce to 5 grams. Okay, so for here the first order reaction rate is given 10 to the power negative 2. So here we can write the equation for T half for a first order reaction, that is 0.693 divided by the rate constant. Okay, so the rate constant will be 10 to the power negative 2. So we can write 0.693 divided by 10 to the power negative 2 seconds. That will be the T half. Now, for the reduction of 20 grams of the reactant to 10 gram, we need one half life because here we are reducing to 5 gram. So we are considering from 20 to 10 first. So it will take 1 T half, right? So in order to convert from 10 to 5, it will take 2 T halves. Okay, so we can write the time required for the conversion will be 0.693 by 10 to the power minus 2 times 2, that is 138.6 seconds, because this is the simplest way to for this calculation, because 20 to 5 means it will take two t halves. Okay, so first t half is 0.693 by 10 to the power minus 2. So 2 t half means that times 2, so it will be 138.6. So this is the way to find out this one. The next question, the rate of a first order reaction is given, that is 0.04 moles per liter per second at 10 seconds and 0.03 moles per liter per second at 20 seconds after the initiation of the reaction. Then what will be the half-life period of the reaction? This is the question. So we can see that the rate of the first order reaction is 0.04 at 10 seconds. So we have to use the equation for the calculation of rate constant. K is equal to 2.303 divided by T2 minus T1 logarithm of a minus x1 divided by a minus x2. We are going to use this equation. Okay. So here at a time 10 seconds the rate is 0.04. At 20 seconds after the time is 0.03. So we can substitute the values. 2.303 divided by T2 minus T1 will be 20 minus 10, because 20 seconds and 10 seconds. Then logarithm of a minus x1. So here a minus x1 will be 0.04 at first time. Next is 0.03. Okay, a minus x1 means the what is the rate? Okay, so that is 0.04 and 0.03 respectively. So rate constant K will be 2.303 times 0.04 divided by 0.03 will be 0.1249 divided by 20 minus 10 is 10. Then we can write the value of K, that is 0.693 divided by T half, that is equal to 2.303 times 0.1249 divided by 10. Then it becomes T half is equal to 0.693 times 10 divided by 1249. So it become 24.1 seconds. So this is the calculation. So A is the correct one. Next question. The activation energy of a reaction can be determined from the slope of which of the following graphs? Okay. So here we have to use the Arrhenius equation. So Arrhenius equation we have A is equal to K is equal to A e raised to minus A by RT. So now we are going to rearrange this equation. Ln K is equal to ln A minus ln A by RT. Right. So here we can see this is equal to, as we discussed before, mx plus c. But here we have a negative sign. So this is equal to y equal to minus mx plus c. So here ln k is y, ln a is c, this is minus mx. So here we can see ln k in x-axis and in y-axis I am taking 1 by t. So I will get a straight line with a slope minus a by r. Okay. So here the answer is ln k versus 1 by t, option B. Next question. When the initial concentration of the reactant is doubled in a reaction, its half-life period is not affected. Then what will be the order of the reaction? Okay, so the initial concentration of the reactant is doubled. That time the half-life is not affected means we can write the half-life will be equal to 0.693 divided by K. So here T half is depending only on the rate constant. So this T half equation, T half is the time required to complete the half of the reaction, right? So even the concentration of the reactant is doubled, the half-life is not affected, means the half-life should be independent of the initial concentration of the reactant. So this kind of relationship we can see in case of a first order reaction only. Okay. So here the T half is equal to 0.693 by K. This is for a first order reaction. So correct answer will be option A. Okay, because for other order reactions, it is depending on the concentration of the reactant. So here the correct answer is option A. Next question. For a reaction between A and B, the order with respect to A is 2 and with respect to B is 3. So the concentration of both A and B are doubled. Then what is the increase in the rate of the reaction? By which factor it will increase? So it is given for the reaction, the order will be 2 with respect to A. So let us consider the reaction first. That is A plus B is converting into the products. Okay. And this is the order is 2 with respect to A, 3 with respect to B. So I can write the rate equation, that is equal to rate constant times A to the power 2, because second order with respect to A, B to the power 3, because third order with respect to B. So here the concentration of both A and B is doubling, right? So I can rewrite after the modification in the concentrations, the rate become, what is happening, the concentration of both A and B is doubling, right? So we can write K times 2A the square times 2B the cube. So we can write it as K, 2A square means it will be 4 times A to the power 2. 2 cube means it will be 8. So 8 times B to the power 3. So I can multiply the constants. Okay. So K is also constant. K times 4 into 8, 32 A square B cube. So K times A square B cube. K times A square B cube here also. That is the initial rate. Initial rate. Okay. So I can write it as 32 times initial rate, because it is equal to 32 times K concentration of A square B cube. Okay. So even if you are increasing the concentration of A and B twice, the rate of the reaction is increasing by a factor of 32. So option C will be the correct answer. So these are the important questions from the chapter Chemical Kinetics. So we have discussed the questions from the past paper 2013 till 2040, 24. Okay, 13 to 24. So these are the important questions. So we have to remember the equations for the calculation of rate, then the T half, then the Arrhenius equation, the graphical relationship, everything we have to memorize. Then the questions will be simple. So try to memorize those equations and try to learn that relationships and try to compare the first order, second order, third order as well. Okay, then it will be fine. So prepare well, all the very best. So for the next class, we will meet with some other chapter, the next chapter. So till that, bye bye.